After completing this module, you will be able to inventory the different kinds of data used in your research, understand ways to store research data, organize, describe, and document your data. Data can come in many forms, such as images, video, survey results, instrument readings, computer models and simulations, code, samples such as plant or soil, and more. It is also important to consider the supplementary or contextual data, such as weather variations, that may be necessary to understand your primary data sources. Once you have identified the data you'll need to manage, you will want to consider where to store the data while you're conducting the study. Imagine the possible short and long-term risks to your data, such as hardware failures, computer viruses, equipment theft, fire, flood, and other disasters. We recommend maintaining at least 3 separate copies of your data. First, the local copy which you work with every day. We call this a working copy. A second backup copy should be kept nearby on a separate device, such as an external hard drive. A third copy should be stored remotely, such as on a cloud server. Popular remote backup services include Google Drive, Dropbox, and CrashPlan. If you are working with confidential or protected data, you'll want to make sure that your remote backup provider can comply with any agreements you've made about your data security. You will also want to test all of your backup and recovery routines to make sure your storage is working properly. Maintaining these redundant copies of your data reduces your risk of catastrophic data loss. To help your team organize your data, it can be useful to develop intentional naming conventions for your data files. When you are naming your files, you should be descriptive. Use file names that make it obvious what the file contains. List files alphanumerically, such as V1, V2, etc. for versions. Avoid terminology such as last or final. Use a year, month, day structure for dates and be consistent. Along with file naming conventions, file directory structure is important for organizing data. Choose a consistent naming convention like you do with individual files. It's a good practice not to overcomplicate your file directory by having too many layers. Next, it's important to describe the steps you took to create and make changes to each file so others can verify or reuse your data. Include this in a readme.txt file stored along with your data, or record it in your lab notebook. Your last step is to provide metadata, or data about your data, that provides context and allows for better access, attribution, and interoperability. This is especially important if you plan on sharing your data in a repository or archive. Metadata describes the content of the data so that it can be discovered and reused. Elements like title, author, creation date, or funding source. Metadata can also communicate other properties of data, such as what software is necessary to open it. Specific kinds of data, such as genomic data, may already have metadata standards that have been developed by researchers to make data easier to discover and use. Data repositories such as Dryad in the fields of basic and applied biosciences will require specific metadata elements. Different disciplines and research methods require different kinds of metadata. There might already be a metadata standard for the data you want to share. The university library's data management site includes other examples of metadata standards. Taking time to consider how to identify, store, organize, and describe your data will help you save time and allow for easier collaboration with others.